Okay, so we're on 2B.2, estimating and solving exponential equations. And again, this is going to be page 76 of your handy dandy notebook, is where we're at. I don't know why my pen decides when it wants to write. All right, let's see if it's writing. Okay, here we go. So we're going to be solving equations. So in the past, we were able to solve linear and quadratics, right? Using elementary operations, addition, subtraction, multiplication, and square root, correct? We practiced that. We just went over that skill. However, we can't use them to solve exponential equations. Did you learn that like 5 minutes ago? Yeah, I know. It's crazy. So what do? Well, before we actually learn what we're going to do, we're going to talk about solving by estimation. So we're going to practice solving by estimation, which means that we're going to find two values where it falls. We're going to give a range of where our answer is, okay? The main thing here is that you have to make sure your exponential is by itself. So like on number 6 in your problem from your assignment, your practice, it said 2 to the x equals 9, correct? Notice that the exponential problem is completely by itself. There's nothing being added or subtracted to it. It is isolated, okay? That is going to be the number one thing to do when you are solving an exponential. All right? Before we get into how to solve it, we're going to start with 2 to the x equals 9. All right? So up here, we're going to talk about estimating. When you are estimating, you are going to choose values of x, plug it in, find a value, and then state a range that fits best, right? So what you're saying here is 2 to some power equals 9. Well, we're going to fill it in. So if I let x equal 0, that's 2 to the 0. And anything to the 0 is what? Yeah. Example 1, problem number 6 from your practice. What does the power of 0 do? Makes everything 1. Okay, if we let x equal 1, that means we have 2 to the 1, which equals what? Equals itself, right? 2. If we have x equals 2, that's 2 to the 2. What does that equal? 4. Are we at 9 yet? Nope. If we let x equal 3, 2 to the third is 2 times 2 times 2, 8. Is that 9 yet? No. Now we're at x equals 4. So 2 to the 4th, what does that equal? 16. So when you're approximating, we now can say that 9 is between where? 3 and 4. So my answer is x is greater than 3, but less than 4. Does that make sense? That's what you're doing with approximating, okay? X is closer to 3 than to 4. Okay, we didn't find the actual answer. To find the actual answer here, you're asking yourself, basically 9's the reciprocal power, but we're not going to talk about that. One number times itself, 2 times what number over and over will give me 9. Well, it's not going to be an exact number, is it? As we can see, it's going to be a decimal value. So we found our approximation. We're going to find how to do this in the calculator in a little bit, but we're not doing it yet. We're just practicing what right now? Approximating, okay? We're not at the calculator part. We're just doing what? Approximating. This is useful, especially on the SAT and ACT when they ask you questions and you have multiple choice, right? And therefore, I can quickly narrow down and eliminate, oh, well, you can't be it because you're bigger than what it should be, okay? So what I want you guys to do at your table is you're going to approximate this one, okay? So you have 3 to the x equals 27. What is the approximate value of my x? 26. I didn't say 27. You heard wrong. Now, is it necessary to start with 0 and 1? Unless you want to. Don't let me stop you. You can put in whatever you want for your x. X is unknown, right? You can put in whatever you want for x.
So I can just say 3 times something. So I can just say 26 minus 3.
It's not division. Remember, we can't use division. We just modeled it. What did we just do to figure out our estimation? We found values of x, we plugged them in, found the value. That's what you're doing. When you think you have the answer, check with your table mate. All right. All right, so when we let x equal 1, just make sure 3 to the 1 equals 3. Bless me. If we let x equal 2,
Yeah.
3 squared is. If we let x equal, she was trying to help you, sir. 3 to the 3rd, what do we get? 27. So from what we have here, what do we know?
X is 2.
There we go. So we know that x is greater than 2, but less than 3. And in this situation, it's what? There you go. X is closer to 3. Does that make sense? Okay, that's how approximating works. Now, what's here? Before I start this one, what do I need to do? I have to subtract the 1 because your exponential term has to be by itself. And this guy is not by itself. So before we do anything with example 3, we're going to subtract 1 from both sides. So we now have 2 to the x equals 29. All right, go finish it. Look back at your other 2 tables if you want. Instead of creating a new one. And add on to that one. Let me know if you need me. I will hobble to you. Or you can come to me. That's probably the nicer thing to do. Yep. Okay, so our last 2 table, we stopped at x equals 4, right? So we knew that x equals 4, and we stopped here, we got that 2 to the 4th equals 16. That's what I said, picking up from that table instead of having to redo that. So now we're at x equals 5. What is 2 to the 5th? 32. Do I need to go any further? No. So we know that X is less than 5, and it's going to be closer to 5. Yes?
Yeah.
Do we feel okay with approximating exponential equations? Okay, so this is useful when you have multiple choice. Instead of having to go full in and solve it, you just use your skills, okay? All right, so now what if we want to fully solve? How do we do that? Well, I'm glad you asked. This is how we fully solve. It's called taking a logarithm or log. Okay, so as you can see up here, this is how you would do the inverse up to the x equals 9. I was like, no one's gonna remember it. So 2 to the x equals 9. What we're actually doing is we're going to use our log rules. We're going to be taking the log of the base and applying it to both sides. That is how you solve it. Okay. So the key thing here is we are taking the log. Okay. That's how it would have worked. And then this is your exact answer. And then you plug in the calculator and you're going to get a approximate. Are you ready to see an example of it? All right. Did anyone get number 6 right? No, I didn't accept you. It's okay. Did you leave it blank though? And that's all I asked. All right. Here are our steps. I assume that you're going to probably have to use pages 76 and 79 in your notebook. It's my thought. 79, 76 and 77. I don't know how I skipped.
75.
We're on 76 right now. Yeah. So the next page is 77 on the back. All right. I'm going to give you a moment. You write down what you want. But these are going to be the exponential steps that we're going to do to solve. So the first thing we're going to do is make sure the exponential term is by itself. By adding or subtracting, then multiplying or dividing to guarantee it's by itself. Then we're going to take the log of the same base of the exponential on both sides. And what this does is the log will undo the exponential, quote unquote, set the power free. Let my power be free. Okay. And then 4, we're going to input the log into the calculator. If you are using a handheld, you're going to press alpha window and you can select the 5th, which gives you log base. Or Decimal Scientific, we will model both. All right. You write down as much as you want or need. I'll give you a couple moments and then we will go through the steps. If you don't think you need the steps, then don't write them. Yes. See. It's behind the door. Where are these 3?
Oh, they're competitive. So all 3 of them are at attention.
Now, I know it's a lot of words for math class on the board, but when you see it, when you see the steps play out, you're like, oh, okay, it's not that bad. All right. Are you ready? Almost. Okay. See how we're using this 95 class minute? All right, so what we're gonna do is we're gonna apply these easy peasy steps and you'll see that it is not terrible, okay? All right, up first, again, you can use page 76 and 77. We're gonna talk about, do you guys don't have to worry about change of base anymore? Back in my day, you know, our calculators didn't allow us to change the base. And we had to know the change of base formula. So it's very, I'm used to doing change of base formula. But I also think it's just convenient when you don't want to have to remember multiple buttons to press on the calculator, my opinion. So this is the change of base rule. Basically, it's saying that if your base is anything other than the common log, which is 10, then to find a solution, you would do log of, I just went blank on what that thing is called. Your argument, the log of your argument over the log of your base, and it's going to give you the same answer. And again, we will model it, but you may not need it. All right, are we ready? So do you guys remember seeing 3 to the x equals 26 of the problem? Oh. 3 to the x equals 26. So first thing we got to make sure, what was step 1 set for us to do? Make sure it's by itself. Is our exponential by itself? Yes. By itself. There's nothing outside being multiplied or added or subtracted, correct? All right, so then we're good to go to the handy dandy calculator. I will model with both. I will model with Desmos and I will model with your calculator. All right, I'm going to turn on my calculator. I'm going to clean second plus 7, 1, 2. And there's a bunch of stuff on my calculator. So what it said here that we're supposed to is that we're going to take the log of our base. So the base of my exponential is what? 3. That's my base. So I'm going to find the log base 3 of my solution, which is 26. I either can type, if my calculator allows me to, I can type it out like that. If my calculator doesn't allow me to, what change of base says is I would write it as log of 26 divided by log of 3. Okay. So either one of these will go in the calculator. Does that make sense? All right. So I'm going to model the first one. To do the first one, if you press alpha window, it'll take you to this little key and you can press 5. There's one way of getting it. Okay. The other way is pressing math. And you would scroll up and it's right there also. So there's 2 ways of getting to log base. I will go over them again. Way number 1 is alpha window. And then you would press log base 5. Founder, right? Way number 2 is math. Scroll up and you ta-da, also finder. Does it matter which way you do it? No, it's really up to you. Okay. And then I will type in log base 3, 26, hit enter. And we get 2.966. Or we write that it was between the values we said and closer to, is it closer to 3? It is closer to 3. Our exact answer, or approximate it, it's going to be. So X is approximately 2.966. That wasn't bad, was it? Okay. All right. I'm going to model it in Desmos. So let me go to my Desmos Scientific. So again, you're using Desmos Scientific. Desmos. Scientific calculator. Come here. So I'm going to go to Desmos Scientific. Once I'm here, you're going to go to where it says function and it has log and you'll click log. Now notice here on Desmo, does it allow me to change my log base? It does not. So what does that mean I need to do? I need to do a division, right? So we would do the log of 26 divided by the log of 3. And do we get the same result? Yep. Desmos Scientific. Okay. So if you're using Desmos, that's where the change of base has to be played out. Okay. How do we feel? Good? Questions, comments, concerns about either one? No? Okay, cool. Good job, guys. Okay, so this was fine in our handheld, right? This one we had to put in our Desmos, but they both came out to be the same. All right. So now you're going to practice example 5. This is still the same problem. Have we not did this problem already? Yes, but now we're going to find the exact value of x. Go. And when I'm on Desmos to get the division symbol, it's the /. So you would do the log, and then press the / button on your computer. Which is next to your shift on the right. Easy, right? You did it easier on that one. I thought I showed you both. You didn't take it from the one. Not making you know one way or the other, right? All right. Are we ready? Okay. So again, your exponential has to be by itself. So like we did it the first time when we were approximating, we subtracted our 1, right? And we were left with 2 to the x equals 29. So I know that this is my base. So to solve for x is going to equal log base 2 of 29 or log of 29 over log 2. Agreed? And what do we get? 4 point. Yes. All right. Let's get a little harder. So let's get a little harder. Okay. So what we need to do here? We need to get our x by itself. Okay. So the first thing we're going to do is get rid of our 2. We're left with 3 to the x plus 1. And we're going to add 2 to this side, correct? And we're now at 102. Okay. What does it mean you're doing when you're adding exponents? What did you initially do? Does anyone remember the rules for exponent? If I'm adding their powers, what was I originally doing with the numbers? I was multiplying them. So 3 to the x plus 1 actually means that you have 3 to the x times 3 to the 1. Because when you are multiplying factors with the same base, you are adding their powers. So this is just a number, right? 3 to the 1 is just what? 3. So in order to get this by itself, what am I going to do with 3? Divide. Because the opposite of multiplying 3 is to divide 3. So we're going to be left with 3 to the x equals, what's 102 divided by 3? You get 34. Now is my exponential by itself. So x equals what then? What's my base now? My base is 3. So we have log base 3 of 34, which equals log 34 divided by log 3. Okay, remember the goal is your x has to be by itself. Oh, that hurt a little bit. Are you already telling me what x is? What's one more digit? Thank you. Gotta practice putting that. If it says 3 decimal places, you gotta include the 0. Okay, this would be relatively as hard as it gets. All right. I said relatively. All right, questions, comments, concerns. All right, so you have your assignment to be working on for the rest of the period. What you don't finish becomes homework, okay? I know. It's crazy, right? It's not due till Thursday.
It's something that's the power of something.